Hi, I'm Travis, CTO here at Proper, and I'm going to be walking you through the features within our orchestration layer today. First, I'd like to speak briefly about what our orchestration layer is and why we felt it was necessary to build. The ledger's job is to maintain transactional data, stay up, and remain performant. However, things like running reporting queries or leveraging search functionality eat away at the performance and speed of any service. Operating a product ledger at scale means you'll need the core running at peak performance at all times. If you expect thousands of transactions per second, but it drops to 25 under reporting load, your business is going to suffer by either dropping transactions or writing them down too slowly to action on with balances. We've experienced those problems at scale in previous organizations, and we've set out to solve them from day one at Proper. With that in mind, our orchestration layer will serve as the entry point for all Proper ledger-related services that augment core ledger functionality, but don't serve the core functionality of writing transactions down and reading balances. Today, I'm going to be walking you through an ACH use case on our orchestration layer. I'm going to create a transaction definition for ACH, and then I'm going to move that transaction through states to make money available for an end customer. So I'll go ahead and open up the transaction definitions. As you can see here, this is an ACH transaction code. So you can define a transaction code, and it's simply a namespace for states. We've called this one ACH. You provide a currency, and so a transaction code operates in the context of a single currency, and then you provide states that the transaction can walk through. This is very much like a state machine. So you can define a workflow that the transaction should follow, for example, pending to complete, or in this case, credit pending to credit. Transaction codes are tied to your tenant, so any naming collision will result in a 400 error. However, you can update the definition should you wish to change it. As you can see here, we've already created an ACH transaction code. So in this instance, I've defined a state for credit pending, credit, and then credit pending reversal, along with credit reversal, but no debit states. You can always update a transaction definition, and so here I've also included debit states, and I'll go ahead and create that. So you can see here that was successful, so now my ACH transaction code has both credit and debit states. At this point, I'm going to go ahead and show you how easy it is to use the transaction definition in actually creating transactions. So here I'm going to go over and create a debit transaction. So the first transaction state is the entry point for that transaction, and you'll need to pass the transaction code you're trying to create, the state that you're hoping to create it in, the ledger you're wishing to use, and the subledger, so the account you'd like to apply that transaction code to. You'll also need to pass the amount, and you can also pass any structured metadata that you wish, and that's all searchable in our system, and I'll show you that in a second. Why don't we just call this Lego, and we can search for that. So we'll go ahead and create this. Now that we've created a transaction definition, I'll walk you through leveraging that definition to move money through a series of states. The entry point for a transaction in this context of our orchestration layer is any initial state defined in the definition. You pass the transaction code, the state, the ledger you wish to apply the transaction to, and the subledger you wish to apply the transaction to, as well as the amount and any metadata you wish to include in the transaction. And this is all searchable, as we'll see in a moment. So I'll go ahead and create this. And as you can see, it was successful. I created a debit pending transaction for the subledger account holder 940 rest of the UUID. And I had some random keys that we can search in a moment. So now what I'm going to go ahead and do is take the transaction we've just created and move it through to its next state, which is a debit. So we had a pending transaction, and this would represent sort of the clearing or making the funds available for a consumer. So the only thing you'll need to pass when you are moving an already created transaction through to another state are the preceding request token and the state you are wishing to move the transaction into. You can also, if you choose, pass additional metadata to be tied to this step in the flow, so this state. I'll change this key here to, let's say, Vader, and then go ahead and move the transaction into the debit state. You can see that was successful. The last thing I'd like to go ahead and demonstrate for you is our search functionality and the ability to query either transaction parameters or any metadata parameters that you've chosen to pass with the transaction or any of the transaction's subsequent states. And so in our previous example, we added some metadata where one of the values was Vader, and so you can see here string searching for the text Vader brings up the transaction we just created. So with that, very powerful search functionality, and allows you to aggregate a number of transactions based on criteria of your choosing.